Every method in this series so far had the same job: shrink the tokens. Fewer output tokens, fewer input tokens, fewer calls, cheaper tokens. Today's method is different. You change nothing about your tokens. Same prompts, same outputs, same model, same quality. And Anthropic still cuts your bill in half. 50% off, input and output. The only thing you give up is time. This is the Batch API. Let's break it down.
Before we move forward, let's quickly recap our 4-layer AI cost reduction pyramid. Layer 1 controls the output by reducing unnecessary tokens and setting a hard max token limit. Layer 2 controls the input using sliding windows, conversation summaries, prompt compression, and RAG. Layer 3 reduces the number of calls through exact caching, semantic caching, rate limiting, and structured outputs with Pydantic. Then we reach Layer 4, reducing the cost per token. We started with model routing, where each request is sent to the most cost-effective model based on its complexity. And now, in this episode, we focus on the Batch API, a powerful option for non-urgent asynchronous workloads that can reduce API costs by up to 50%. Instead of paying full price for tasks that do not require an immediate response, such as large-scale document processing, evaluations, classification, or report generation, we submit them as a batch and let the provider process them in the background at a much lower cost.
So what exactly is the Batch API? Normally, you call the Messages API synchronously. One request goes in, you wait a few seconds, one response comes back. Real time, perfect for chatbots. The Batch API flips this. You bundle up to 100,000 requests into a single batch. You submit the whole batch in one shot. Anthropic processes them asynchronously on their schedule, not yours, and guarantees results within 24 hours. In practice, most batches finish much faster, often within an hour. And because you gave up the real-time guarantee, Anthropic gives you 50% off. Both directions. Blue input tokens, half price. Amber output tokens, half price. No quality difference. It's the exact same model, producing the exact same responses. This infographic compares synchronous API processing with the Batch API. On the left, the synchronous flow handles one request at a time. The request is sent, the user waits around 2 to 3 seconds, and the response returns immediately. This real-time approach is ideal for chatbots and live applications, but it uses the standard 100% token rate. On the right, the Batch API groups up to 100,000 requests and processes them asynchronously. No one is waiting for an instant reply, and the completed results are returned together within 24 hours, usually much faster. In exchange for giving up real-time delivery, both input and output tokens are charged at only 50% of the normal rate. So the rule is simple. Use synchronous processing when you need an answer now, and use the Batch API when you can wait and want to cut the cost in half. Now that we understand what the Batch API is, let's see how the workflow actually works. The full process can be broken into 3 simple stages. Create the batch, wait for processing, and retrieve the results. First, we prepare multiple requests and give each one a unique custom ID. Then we submit them together as a single batch for asynchronous processing. Finally, once the batch is complete, we download the results and use those custom IDs to match every response back to its original request. Let's walk the workflow. 3 steps. Step 1. Create the batch. Each request in the batch looks exactly like a normal Messages API call. Model, max tokens, messages, wrapped with one extra field, a custom ID. That custom ID is yours. You choose it, and it's how you match each result back to the request that produced it, because results are not guaranteed to come back in order. Step 2. Wait. You poll the batch status or register a webhook so Anthropic calls you when it's done. The status moves from in progress to ended. Step 3. Retrieve results. You stream down a results file. Each line carries your custom ID, a success or error flag, and the full message, including our old friend, the usage block. Yes, the cost meter is still there on every single result. Your token accounting from the whole series carries straight over. Hello, this is the lab part. In this lab, we will show how to implement batch API call and all related methods for this created batch, to know the status, to know the feedback of the model, to know how to delete or to cancel it. Let's start. First, we will create your batch. First step is creating your batch. This is Claude syntax you use to create your batch. First is using client.messages.batches.create. Here I make a create for the batch, and this batch will involve two requests. This is the first request, and this is the second request. In every request, it has its own user query, different than the other request. Here is a user query, and this is other user query. Now you created the batch. After creating the batch, this batch is asynchronized, meaning you didn't have any information about the status of created batch, and did not get on-time respond from the Claude model. So I need some method to know what is the status of this created batch. This method first will show that to retrieve. To retrieve here, .retrieve. Retrieve need batch ID as input. This batch ID, I give it the batch ID already created above from the .create for Claude, and then using this batch ID to retrieve and to know the status. Now you see the status of this. This batch here have 5 different options: canceled, errored, expired, processing, success. Here is the status of success, and this 2. 2 means 2 count number of requests involved in this batch. So .retrieve here, I know what's the status of my 2 requests involved in one batch. Here, to know what's the status also, but number of processing. So here I make the .retrieval for message batch ID, and here I make for while loop and put time.sleep. So after 6 seconds, you check what is the status, and print the status after each 6 seconds, means after 1 minute. So this after 1 minute, it's still processing. Second minute, it's still processing. After 2 minutes, it shows the results. The result now becomes successes with 2 number of request ID in this batch. Number 3 is .list. .list here to list all the batches from history till the newest one. Here, once I run this command, it gives me the last batch ID in first output, and the all those one appears in the last item of the print. So this is the newest batch I created, .list. Then we go to know what is the result or what's the feedback of the model about the user query in this batch. Here we use .result. For .result, to know what the feedback of the model for the 2 requests is, here is the feedback. This for request 1. This is user query, and this is the feedback of the model. And this for second request, and this is the model Claude answer message. Last one, if I want to make a cancel. If you want to cancel this batch, the batch must be in processing state, not ended. So once already I run this command, .cancel. You know what the output of this, it give an error. And the result of this error, it says, this batch can't be canceled because it has already finished. So, if you want to cancel, you have to make sure the batch status in processing, not already successful or finished. That's it, our lab for this session. In this slide, we will explore all available methods under the Anthropic Python SDK's client.messages.batches. The Batch API allows us to submit many message requests together, process them asynchronously, and retrieve the results later. It is especially useful for large-scale workloads that do not require an immediate response. There are 6 main methods: create, retrieve, list, results, cancel, and delete. Let's go through them one by one. The first method is create. We use create to submit a new batch containing multiple message requests. Each request should include a unique custom ID, along with parameters such as the model, messages, and maximum output tokens. After submitting the batch, its initial status is normally in progress. The second method is retrieve. We use this method to check the latest status and information for one specific batch. We provide the batch ID, and Anthropic returns details such as the processing status and request counts. There are 3 main processing statuses. In progress means the batch is still processing. Canceling means a cancellation request has been submitted. And ended means that batch processing has finished. The third method is list. This method displays previously created batches, normally with the newest batch shown first. We can control the number of returned batches using the limit parameter. We can also use after ID or before ID for pagination when we have many batches. The fourth method is results. Once the batch status becomes ended, we use results to retrieve the individual response for every request inside the batch. Each request can have one of 4 result types: succeeded, errored, canceled, or expired. An important point is that the results may not return in the same order as the original requests. For this reason, every request should have a meaningful and unique custom ID. The custom ID allows us to match each result with its original request. The fifth method is cancel. We use cancel when we want to stop a batch that is still processing. The status normally changes from in progress to canceling and finally to ended. However, some requests may still complete if they were already being processed when the cancellation request was submitted. The final method is delete. We use this method to remove a batch after processing has finished. An active batch cannot be deleted. We must first wait until its status becomes ended and then call delete. Now let's look at the normal workflow shown on the right side of the slide. First, we create the batch. Second, we use retrieve to check its status repeatedly. Third, when the status becomes ended, we call results to get the individual responses. Finally, we can delete the batch when it is no longer needed. The early cancellation workflow is slightly different. We create the batch and then call cancel while it is still processing. After that, we continue using retrieve until the batch status becomes ended. We can then call results to identify which requests succeeded, failed, expired, or were canceled. Finally, we can delete the finished batch. To summarize, create starts a new batch. Retrieve checks its status. List displays previous batches. Results returns the individual responses. Cancel stops an active batch. And delete removes a finished batch. The most important best practice is to assign a clear and unique custom ID to every request. This ensures that every result can be correctly matched with its original input, even when the results return in a different order. And that is the complete lifecycle of the Anthropic Message Batches API. Now let's run our numbers. Same baseline as every episode. 1 million requests per month. Average 2,000 input tokens and 500 output tokens per request. Sonnet class model at $3 in, $15 out per million tokens. Synchronous cost. Input 2 billion blue tokens, $6,000. Output 500 million amber tokens, $7,500. Remember our 5-to-1 rule. Output tokens cost 5 times input, so output dominates again. Total $13,500 a month. Now suppose 60% of that traffic fails the one-question test. No human waiting. Nightly summaries, labeling, moderation. Move those 600,000 requests to the Batch API. That slice drops from $8,100 to $4,050. Your new total, $9,450. $4,050 saved every month. And you didn't delete a single token to get it. And that's the Batch API and the final technique in our AI cost reduction series. The idea is simple. Not every AI request needs an instant response. For chatbots and live applications, synchronous processing still makes sense. But for summaries, classification, moderation, evaluations, and large-scale document processing, no human is sitting there waiting. That is where batching becomes powerful. You send many requests together, Anthropic processes them asynchronously, and you receive the same model quality at half the input and output token rate. In our example, moving only 60% of eligible traffic to the Batch API reduced the monthly cost from $13,500 to $9,450. That is $4,050 saved every month, with the same model, the same requests, and the same number of tokens. So before sending any AI workload in real time, ask one question. Does someone actually need this answer right now? If the answer is no, batch it. And with that, we complete all 4 layers of the AI cost reduction pyramid. We controlled output, reduced input, cut unnecessary calls, and lowered the cost per token. Across this series, we cover practical techniques like max token limits, sliding windows, summarization, prompt compression, RAG, caching, rate limiting, structured outputs, model routing, and finally, the Batch API. The biggest lesson is this: AI cost optimization is not one trick. It is a stack of small decisions working together. Each technique saves a little, but at scale, those savings compound into something massive. Same capability, less waste, smarter architecture, lower cost. Thank you for following the full AI cost reduction series. I hope it helps you build AI systems that are not only powerful, but also efficient, scalable, and financially sustainable. This is Human Mimics AI. Thanks for watching, and I'll see you in the next series.